Okay, here we are at the end of chapter 5. This is 511. We will only be spending one day here. And this one more time, we are going to find the area under the curve. I have to laugh. It's been, I don't know how many ways we've done it, but there's still one more way. And this way is called Simpson's rule. Simpson's rule finds the area under the curve using parabolas. Okay, so if you go back and count all the ways we found area under the curve, you're going to just crack yourself up. We've done it so many ways. So, two things to keep in mind with Simpson's rule is you have to have the area must be divided into an even number of subintervals. In order to do this, you need an odd number of x values. And I'll explain subintervals when I make the sketch. So we need an even number of subintervals, but they could have just went with you need an odd number of x values to do it. Okay, and the subintervals must be all the same width. So subintervals must be the same width. So say we've got a function does that little trick. I'm just going to do one little chunk of it. Let's say from A to B. So what we will do we have to divide it into an even number of subintervals. So the smallest number we could use is 2 subintervals. So what that does is it puts another divider through here. Okay, so that I'm using 3 x values. And then instead of calling the first one x1, they call it x sub 0. I have no idea why. That puts the second one as x sub 1, and then x sub 2. Maybe so it ends in an even number. I'm not really sure. So what the Simpson's rule does is it takes these 3 corresponding y values. So this would be considered y sub 0 because it's the y value for the x sub 0. This one would be y sub 1. And this one would be y sub 2. It takes those and finds a parabola that would go through these. So like maybe the best fit parabola would be one that did this. And find the area under that parabola. And then I would, if I wanted to extend my B out, I just keep making more of the same width subintervals and go y3, y4, y all the way out to the end wherever I might have B at. Okay, but the way Simpson's rule works, if we call this f of x, this original equation f of x, to get the area under the curve from A to B of f of x dx using Simpson's rule, and it's just a little plug and tug formula, he said take 1/3 times your change in x, delta x. Your delta x is how wide you've chosen to make your subinterval. So there's your delta x. It's that width, and that's constant all the way through. Times, and then just like our Pascal's triangle when we did the binomial expansion, we had those multipliers out in front. We have the same thing here. Okay, the way Simpson's rule, the way the pattern works, the pattern goes 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 1. Has to end with that 1. So again, it's 1, 4, now 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 1. So 1, 4, 2, 4, 2, 4. Oh, I need one more in here. Dang it. Because it has to end 2, 4, 1. Oh, maybe I want to make that a little bit longer. Put some dots in the middle. I'm going to redo this line. Make it a little bit longer so you can see 1/3 delta x, the pattern. So it's 1, 4, 2, 4, 2, 4, dot, 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 and it has to end 2, 4, 1. It always has to end, and it will if you've got the right number of x values. Okay, so there's your pattern. They won't be this long. They'll probably end back in here. So, but wherever you need to, you end at 2, 4, 1. And then all you have to do is multiply by your y values in order, starting with that y sub 0. So it's y sub 0, y sub 1, y sub 2, y sub 3, y sub 4, y sub 5, all the way to y sub n. I'll call this one y sub n minus 1 and y sub n minus 2. Okay, it's a very, very easy formula to work with. It might look complicated, but it's not. The key is you just have to have an odd number of x values, which makes an even number of subintervals. These are the subintervals. There are 2 subintervals here. So the only time you would have to use Simpson's rule instead of doing our little integration rules like we've been doing is if they give me a table of points instead of an equation. So, and this was an approximate, by the way. I shouldn't have put equals in there. That's an approximate value. It's not an exact. So, for example, let's see, can it fit on here? I'll go horizontally, it will. Example 1. I want you to approximate the integral from 2 to 14 of f of x dx if all I give you is a table for x and f of x. And I'm going to have to make it a horizontal table to fit it on this page. So x and f of x. My x values are going to start at 2 and go evenly. So 2, 4, 6, 8, 10, 12, 14. Okay, my y values, corresponding y values are 28, 43, 37, 33, 47, 68, and 55. If we take the time to make a quick little sketch of this, and I'll go, I wish I hadn't made that line quite so long. So 2, 4, 6, 8, 10, 12, 14. Squeeze that in there. I need my graph to go up to 55. So if I go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Went by 5s and made it kind of small. I'm just going to do a quick sketch. 2 to 28. 4 to 43. I should have wrote some of these in. 10, 20, 30, 40. So 43 out there. 37, 33, 47, 60. Oh, geez, that one's way up there. 68, about up there. And then back to 55. So I am going to find the area under that curve using Simpson's rule. That's the only rule I have. I have no equation that gave me these. So we'll approximate it with Simpson's rule. Simpson's rule, going to chunk it up. And you can see they're all evenly spaced. They're all a width of 2. And it'll do it with finding the area under each little parabola. That's what his formula does. This next parabola would be upside down like this one. And then here's the third one. So it's going to find the area of those 3 parabolas in there. I must have 6 chunks. 1, 2, 3, up 4, 5, 6. 6 subintervals. Not that that's important. Okay, Simpson's rule. All I've got to do is follow the formula. It's 1/3 always times delta x. That's the width of my subintervals. All of these, if you look, were 2 apart, all evenly spaced. If they were not evenly spaced, I would not be able to use Simpson's rule. So times by the width of 2. I've got 1, 2, 3, 4, 5, 6, 7 y values, so I need 7 multipliers. There's my 6 and 7. The pattern, 1, 4, 2, 4, 2, 4, 1. It has to end 2, 4, 1. So 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 1. Okay, now I just put the y values in order. First one was 28, so times by 28. Times by 43. Times by 37. Oh, forgot to put big old plus signs between all these terms. I guess you wouldn't. I could have guessed that maybe, but you're adding. So plus, plus, plus. Let's see, I was at 33. Plus 47. Plus 4 times 68. And plus 1 times the 55. Okay, right there, all plug and chug. There's nothing too complicated in there. I think everybody can get that one. If you do that correctly, you get something I don't have written down, of course. Oh, I'm not going to type that in for you. I think you can do that. 1/3 times 2, parentheses, all that just like you see it. We'll call that good. So that's your Simpson's rule. Again, the only time you would use Simpson's rule as opposed to integrating is if you don't have an equation. I don't have an equation here. All they gave me was a table. So I can't do a power rule on a table. So this is our technique we're going to use. Now, one more thing is, you know how we just got done doing all those integrals with boundaries using that fundamental theorem of calculus when we actually have an equation? You could have checked all of those on a calculator. You have a button on your calculator that will integrate if you know the boundaries. And so that's what we're going to do now. And the reason we're doing it now is most calculators use Simpson's rule to find the area under the curve or to integrate an equation. So integrating from a to b of f of x dx is approximately equal to the function integrate value on the calculator. So I'll tell you where that's at in a minute. Function integrate, you're going to type in your equation, comma x, comma, and then your boundary values, the smallest one to the biggest one, so it's a to b. So your bottom boundary to your top boundary. So you're putting in 4 things when you use function integrate. Now, if you've got that newer operating system, yours is going to look slightly different than mine, but you're still going to have to input 4 things. The equation, an x, and then the a and the b. Oh, I think they actually give it to you in this format. So it would be a and b, f of x, and then your x goes right there next to the dx. I think, if I remember correctly. Otherwise, first of all, where it's at, it's under math. It's under math.